Welcome. We can connect up to 4 CS548s to make a 16 isolated channel oscilloscope. Why so many? Consider an EV charging station. It could have a 3-phase power factor converter followed by a full bridge isolated DC to DC converter as in the diagram. We want to measure efficiency, so that's 3 input phase voltages and currents and 1 output DC voltage and current, a total of 8. We might also want to measure the efficiency of each section. Add an extra DC voltage and current channel. That's another 2. Then we might like to look at all the gate drives to check for timing, dead time and shoot through. Another 6 channels in the PFC and another 4 in the DC to DC converter. That's 20 channels total. Oh well, some compromise has to be made. We only have 16 for now. Anyway, let's connect up the scopes. The first job is to connect the link cables from the link out port on one scope to the link in port of another. Here I've connected up 3 scopes. Note the cables are 500mm HDMI cables. Use ours and don't fit a longer one. We know the delays of ours. I have connected the signal generator to a 4-way splitter with 4 equal length coax cables attached to it. Plug in each coax cable into the A channel of a scope. Using this arrangement, we can measure the phase difference between units and also make sure the amplitude of the measured signals is the same for each unit. We've connected up the 4 units so that can be used as a 16-channel scope, but we still have to do the work of making that happen. Just for the moment, we are using a single unit to capture a 50 nanosecond pulse. We are using a 20 kHz square wave with a duty cycle of only 0.05%. The filtered SIG-gen output adds some oscillations, which are interesting to look at. We've also got the tracking display set up so it's displaying the same waveform. So we'll just keep that in our back pocket for now. So, how to do this? Go to Settings, choose Acquirer, and at the moment we've just got 1 unit connected. We wait for all the other ones to become available. We're going to do them in order so that channel A is on the left. This one's going to be 07, this one's going to be 08, and this one's going to be 10. So there they are, they're all connected. Now we have to make sure the link cables are installed, which go from link out to link in between all the scopes. So it's connecting, and at the moment we've only got 1 set of channels displayed, but now that the rest of them have appeared, we've got 4 sets. This is the first unit, the second unit, the third unit and the 4th unit. We're using alpha channel numbering. We can change the channel numbering using Settings, Analog Names and Units. We can change it to 1 to N instead, but we must use the default names and units. So we do that. Now they're all labeled as numbered channels. This is a bit easier if you've got lots of channels. I'm going to set persistence to 50 triggers on each scope. This will show us the time alignment variation. We're using the A channel for each scope. Let's start. It's capturing. Now, what happens if we zoom out? Let's try that. We'll go out to about 24 milliseconds total capture period. Let's capture that. We've got 24 milliseconds of capture period. The resolution of the waveform in the scope is 2.5 nanoseconds. We're only showing 10K. We're using peak captured to make sure that we see all of the peaks. Peak captured means that a small pulse, 15 nanosecond wide, gets resolved and displayed even though the graph dt is only 2.4 microseconds. Let's bring in the tracking graph again. And we can see that the tracking graph is also displaying that same one pulse that we saw before for all channels. Now let's see how well aligned they are. You can see that as I raise each one up, it's there, it's just hiding in the background. And there's the last one. So they're all aligned again. So we've got very good alignment of all the channels. If we zoom in here, this is 1 nanosecond per division. You can see the dispersion between the channels is plus or minus about 150 picoseconds. As you can see, we can capture 16 channels. Time alignment is really good, and amplitude alignment is really good too. Thanks for watching.